to go over a few questions from the review, specifically the last group of problems from the review worksheet. Looks like there were questions on those solving equations. So we will look at those. Just a little reminder for that test tomorrow. You can use the identities and formula sheet that I gave you in class. So you are permitted to use that identities and formula sheet that I gave you in class on the test tomorrow. If there are any notes that you want to make to yourself on that formula sheet, any comments that you want to remember, you can put it on that sheet. Or if there's like an example that you wanted to remind yourself about, you can place it on that formula sheet. So that will be for tomorrow. If you're at home, I ask that you also print out that sheet and then place some comments on there. So those of you at home, I'm truly asking for academic honesty on this. We have a quarter of the year left. So like you really need to use academic honesty and prepare yourself for either AP Calc next year, CHS Calc next year, AP Stat, depending on the math class you're taking next year. But we need to, like, at this point, get in the thought process of we've got to start preparing for regular school next year. So let's look at the review worksheet. And I'm going to briefly talk about number 8. And then I had 14, 15, and 17 that I thought we would look at. But number 8, I started it. And a really good question that you might want to make a note for tomorrow, when you're looking at the answers, number 8 is the minus and not the plus. And the question is, why is your answer a minus square root instead of a positive square root? So I first started this. It's asking for the cosine of the half angle. And I replaced the formula and I used cosine, which is 12 over 13. And I did a little bit of simplifying up until the point where I have plus or minus root 25, 26. So if I continue to simplify that, you can take the square root individually. So you end up with 5 over root 26, which is really plus or minus 5 root 26 over 26 rationalized. So don't forget about simplifying it. I can take the square root individually when a fraction is underneath. That's called the quotient property of radicals. So there's a plus or minus in front of this. And that is because cosine is positive in 2 quadrants and it's negative in 2 quadrants. If you look at the given information, we're talking about the cosine of y over 2, and they tell us that y is in quadrant 4. However, you're not finding y, you're finding y over 2. You're finding the half angle. So that means y is in the 4th quadrant, but the half angle is not in the 4th quadrant. And in order to decide if it's a plus or a minus answer, you need to determine the quadrant of the half angle. So if I have the 4th quadrant, Peter, what angles would be like located for the 4th quadrant? Can you give me like an inequality that represents the angles of the 4th quadrant?
It would be where the y is greater than 3 pi over 2 and less than 2 pi.
Yeah, thank you. So he said greater than 3 pi over 2, but less than 2 pi. And he said why? Because that's the given angle. However, you want the half angle. So that means I want y over 2. So if I cut all of this in half, now I have it being less than pi. Oops. And if I cut this in half, it's really multiplying by a half, I have it being greater than 3 pi over 4. So the half angle is between 3 pi over 4 and pi. Peter, where would the half angle be located?
The half angle's in the second quadrant.
Yeah, the half angle's in the second quadrant. So the given angle is in the fourth quadrant, but you're finding the half angle, and that's in the second quadrant. So the question was dealing with the cosine of the half angle. Cosine is negative in the second quadrant. That's why their answer is negative for number 8. So that is something that you might want to note to yourself. If you're finding the half angle of sine or cosine, either one of those, you need to know the location of the half angle. Even though they give you the regular angle, you're finding the half angle, and you've got to understand where that half angle is located. So number 8 is negative because the half angle is in the second quadrant. Questions on that? All right, so let's go down. And so we're going to start with 14. We'll do 15 and 17. 14 wanted you to prove the identity. And we have 2 times sine times cosine times secant 2y. And we're trying to make that equal to the tangent of 2y. Well, this secant of 2y, that's double angle notation. So just ignore that for a minute. And look at the 3 pieces in front of that, the 2, the sine, and the cosine. So kind of think that the secant 2y is its own separate notation. Does 2 times sine times cosine represent an identity or formula that we discussed in chapter 5? Joe, do you know, does 2 times sine times cosine represent an identity or formula that we discussed in chapter 5?
It would be the sine of 2y.
Yeah, so this is the double angle formula for sine. That's the expanded form. That's the actual formula that represents the double angle of sine. So instead of saying 2 sine cosine, we can say the sine of 2y. Now let's think about that secant of 2y. Joe, what is another way of thinking about it being the secant of 2y?
1 over cosine 2y.
Yeah, the reciprocal of secant is 1 over the cosine. And now we have sine 2y over cosine 2y, which is the tangent of a double angle. So recognizing that first piece there is really the notation or the formula for the sine of 2y, and it condenses into that notation, sine 2y. Questions on 14? All right, let's look at number 15. Find the specific solutions in the interval of 0 to 2 pi in radians and in terms of pi. That just means your answer should be pi over 3, 5 pi over 3, 7 pi over 4. So your answer is going to be an exact angle. So looking at the problem, kind of like see if you can recognize the notation. So I see this cosine 2x, that's a notation for a formula. And then I see this 5 cosine x plus pi. Well, cosine x plus pi, that's also notation for a formula we talked about. Jenny, do you know if we have the cosine of 2x? How else can I write the cosine of 2x?
I made it 2 cosine squared minus 1.
Yeah, and that's a good idea, keeping it in terms of cosine, because there's another cosine in the problem. So remember, cosine is the one that has 3 different formulas. Pick the one that is represented in another part of the problem. Don't introduce a different function if you don't have to. So she said she used 2 cosine squared minus 1. So that's the one of the 3 double angles for cosine. Jenny, what do you know about the cosine of that x plus pi? What's that?
It looks like the sum formula for cosine.
Yeah, it's the sum formula for cosine, but it's all being multiplied by 5. So we have 5. And then Jenny, what is the sum formula for cosine?
It's cosine of x times cosine of pi minus sine of x times sine of pi.
Nice. And then that's equal to -3. So first formula, double angle. Second formula, sum of the cosine, the sum of two angles for cosine. Now you can look inside those parentheses and evaluate it a little bit. So if we want to evaluate this, we want to figure out what is the cosine of pi, or what is the sine of pi. So Hannah, if we have the cosine of pi, what is the cosine of pi, Hannah?
Would it be 0? Or I mean -1.
Yeah, so the cosine of pi is -1. And Hannah, the sine of pi is
0.
0. So looking to see what we have 2 cosine squared minus 1. And now inside we have cosine times -1. Well, that's negative cosine. And then that has a 5 outside. So that would become -5 times the cosine. The next term says negative sine x times 0. Well, if I'm multiplying anything times 0, that part goes away. So we're just left with -5 times the cosine. And it's equal to -3. So again, replace the cosine of pi and the sine of pi with their actual values. So Hannah, where do you think you would go from here?
Could you move the 3 to the other side and then factor?
Yeah, let's get this set equal to 0. So if we move the 3 to the other side and rearrange this, set it equal to 0 and factor it. So we're looking at a 4. That means we have 2 cosine squared minus cosine minus 4 cosine plus 2. So we are trying to make a -5. And then I could pull out a cosine. And I can pull out a -2. Sorry, this isn't supposed to be here. That's just supposed to be a 2. So factoring cosine minus 2, 2 cosine minus 1. So you did all the algebra, you did all the trig. We just have to find the angle answer. So a little bit more trig remaining. Gianna, the cosine of x equaling 2. Is the cosine ever 2 on any of the angles of the unit circle?
No, so it will be undefined.
Yeah, that one's undefined. The max value of cosine is a 1. It goes from -1 to 1. And then Gianna, when is the cosine 1/2 on the unit circle?
At pi/3 and 5 pi/3.
Excellent. So cosine is the x. It's 1/2 at pi/3 and 5 pi/3. Questions? All right, so 17, the last problem on here. We have the sine of 2x times the sine, cosine of 2x times the cosine, and then it's equal to 1. Did anybody start this problem? Any thoughts about where to go, what to do?
Wouldn't you pull out the 2x for the formula for sine 2x? You would make it 2 sine cosine, or but
Okay,
then it would be
yep.
2 sine squared once you multiply it.
Nice job, Darby. So she said, let's start with that sine 2x. That's the double angle formula. So she said, replace that. And then there's already a sine there. So Darby, what was your next thing then that you said with those two pieces there?
You can combine them, so it'll be 2 sine squared times cosine.
Excellent. So the sine of the double angle changes into the double angle formula. There was already a sine being multiplied, so that becomes 2 sine squared times cosine. All right, so that's the first part of the equation. Darby, how about the second part of the equation?
I did the 1 minus 2 sine squared and then times cosine because
Okay.
that's like one of the identities.
Yep. So you said you made this 1 minus 2 sine squared. So you're replacing the cosine of the double angle. That's one of the 3 identities. And then that whole quantity that you replaced is still times cosine. So Darby, what happens when you distribute the cosine through? Because all of that quantity is multiplied by cosine. What does that become?
Then it's cosine minus 2 cosine squared.
You're close. So
Oh,
cosine minus 2
sine
sine
squared
squared
cosine.
times
Okay, yeah.
There you go. And then it's still equal to 1. So replacing both of those formulas. So you have the formula notation, you're replacing it with the actual formula. And then if you look up like the whole equation here, it looks big, but Darby, what happens?
The 2 sine squared cosine on the ends of the problem both cancel.
Yeah, so we have a positive and a negative, 2 sine squared cosine, 2 sine squared cosine. They cancel. And all you have left is the cosine equaling 1. So it looks like a daunting problem. Holy cow, there's a lot of stuff here. But things cancel and you get the cosine to be 1. Peter.
I have a question. I made the cosine of 2x. I made it the cosine squared minus 1, or the
Mhm.
2 cosine squared minus 1. So when I distributed it, I got 2 cosine cubed minus cosine.
All right,
And
so
then
let's look here. So this is way 1. Peter said he used the other, one of the other formulas, and he distributed this, and you have 2 cosine cubed minus cosine. All right, so for those of you that tried the other formula, this is another way. Remember, there's multiple ways to work through these trig equations. What else did you do then, Peter?
I pulled a cosine out, a 2 cosine out of the equation, out of the entire equation.
And then you made that last one like a minus 1/2.
What do you mean a minus 1/2? Like I factored out a cosine, a 2 cosine from the entire equation, and then inside the parentheses, I got sine squared plus cosine squared minus 1.
So it wouldn't be minus 1 because you factored out a 2 and that doesn't have.
Oh, okay.
And then the only problem with that, Peter, is when you factor, it has to be equal to 0.
Okay.
But I want to show you how you can, because like this does work. So if you started the problem this way, what Peter did, I do want to show you how this works out. Peter, there's a sine squared in the front here. Everything else has cosine in it. How could you change sine squared?
Would you make that 1
Yeah, so if we make this 1 minus cosine squared, still times cosine, plus 2 cosine cubed minus cosine. And then if we distribute cosine through the parentheses and the 2, I'm going to do it really, I'm multiplying 2 cosine through the parentheses. So we end up with 2 cosine minus 2 cosine cubed, and then plus 2 cosine cubed, and then minus cosine. So looking at the problem, terms still cancel just like they did the way Darby did it. But this time we have a negative 2 cosine cubed and a positive 2 cosine cubed. And then we have 2 cosine minus 1 cosine. So you still end up with cosine equaling 1. You just get there, maybe at an extra step or 2, but you still get to the same place. So even if you use a different formula, it still can work. It's just as long as you like algebraically are working through the problem correctly. And sometimes that's the trickier part. You know the trig, but it's doing that correct algebra. So this would have been the second way that you could have worked through that problem. Questions. So Darby's way might have been shorter, but it really depends on how you start it. So once you start it, if it doesn't work for you, try a different formula. If you can't get it to work the first time, maybe try the other formula to see if you can get it to work out. Questions on number 17? All right, so I want to show you the other review worksheet, and then if anybody has any other questions, you can feel free to ask. But I do want to show those of you that don't have questions the other review worksheet on Google Classroom. So if you want to travel over to Google Classroom, the review worksheet is posted. So you can open up that chapter 5 review worksheet. There are 10 problems on this chapter 5 review worksheet, and they're kind of just random. There's not a pattern to them. Each problem is different from the previous problem. So the review worksheet does start at the very beginning of the concepts that we've discussed in chapter 5. The first one says verify. You have tangent to the fourth plus 2 tangent squared plus 1. That looks like a factoring problem. You want to change that to be secant to the fourth. So it looks like factor that left side to help you verify. Number 2, we have secant squared plus cosecant squared, and then on the bottom, cosecant squared times 1 plus the tangent squared. So again, this is a simplifying problem, exactly like what we talked about in section 5.1 and 5.2. Numbers 3 and 4 and 5, these 3 questions are very similar. Use the sum or difference formula to find the tangent of 15 degrees. So that means I need 2 angles on the unit circle that we have memorized that are special angles. That would combine together to give you 15 degrees. Well, 45 degrees minus 30 degrees give me 15 degrees. So that means I would be using the difference formula for tangent. Number 4 wants you to find the exact value of the cosine of 120, but you're asked to use the double angle formula. So yes, I know the cosine of 120 is on the unit circle, but I want you to just practice that double angle formula. So use the double angle formula for cosine. And then number 5, you're using the half angle formula. So those 3 problems using angles on the unit circle, just kind of practicing those 3 formulas. Looking at number 6, you're finding the solutions for number 6. You're finding solutions for number 7. So 6 and 7, you're finding solutions. And then 8 and 10 are drawing triangles. And again, just finding what they're asking for. So find the cosine, the tangent, and the half angle. Or number 10 says find all 5 trig functions. So kind of a mix of problems from chapter 5. So I would say tonight, kind of look at the homework problems that maybe you didn't solve correctly the first time. Look at any homework problems that we went over in class, that we discussed in class, any that you found more challenging. There were many different worksheets that we covered, so maybe just glance at those worksheets that we've kind of used throughout the chapter and see if there were any problems on there that you couldn't solve correctly, but we discussed it in class. Like, look over those problems tonight as well. The test tomorrow, remember, you don't get any extra time. It's a 40-minute test. It might be one of the most challenging tests that you take, but you get to use an identities and formula sheet, and you can write some notes on there for yourself. But there are 11 questions on the test tomorrow. It is 48 points. The first 6 questions are like the first 6 questions of yesterday's homework, or I should say the homework that was due today. And I consider these like free questions. So these first 6 questions should be freebies. You have an identities formula sheet to use. It's like a matching game. So you can know that you've got 6 questions that should be pretty straightforward for you to quickly work through and identify the function. But you should at least be familiar with the notation. You don't want to spend too much time kind of looking at that formula sheet. So you can feel free to remain on and ask any other questions that you have. Otherwise, you can leave and have a fantastic day. If you're in school tomorrow, I strongly suggest if you have any questions, feel free to stop by before school. I get there around 6:45-ish, 6:50. And of course, homeroom starts at 7:20. But you can feel free to stop by my room in the morning. If you are not coming to school tomorrow, please email me if you have any questions that you'd like to go over. So if you're leaving, have a great day. We'll see you tomorrow.